Welcome to the San Diego SkyTram project, brought to you by BRAGSS Engineering. Allow me to introduce you to the team.
Sebastian Garcia, Structural Engineer.
Patrick Scott, Environmental Engineer.
Abelardo Solis, Transportation Engineer.
Norberto Rubalcaba, Geotechnical Engineer.
Dave Arthur, Structural Engineer.
Daniel Bedoya, Construction Engineer.
Earlier this year, County Supervisor Ron Roberts announced that he would like to add a SkyTram for San Diego from Balboa Park to downtown. The project will help to establish San Diego as a leader in sustainability, as well as provide beautiful sky views of the San Diego skyline, Balboa Park, and the ocean. It will be approximately 2 miles from the trolley station on 6th Avenue near Petco Park to the open fountain courtyard in the heart of Balboa Park. The north-south alignment will go up 6th Avenue until it reaches El Prado, where it will turn and finish its final approach into Balboa Park.
Hello, my name is Patrick Scott. I'm an environmental engineer, and I did the environmental studies section of the San Diego SkyTram project. For this project, the two areas of concern were downtown and Balboa Park. Since downtown San Diego is classified as 100% urbanized and built-up land, the main environmental focus landed on Balboa Park. The purpose of this section was to identify any environmental red flags associated with the project and then create mitigation measures to lessen the impacts. The California Environmental Quality Act, or CEQA, was used to determine the areas of environmental concern. Appendix G of the CEQA guidelines provides an environmental checklist. As can be seen, the words in red signify environmental impacts of this project, which include aesthetics, biological resources, cultural resources, geology, noise, public services, recreation, and hazards. Listed here are some mitigation measures for the main environmental impacts of the project. For aesthetics, we decided that the landing zone in Balboa Park should match the surrounding architecture and be surrounded by familiar foliage. For biological resources, the impact will be minimized by monitoring construction and placing the footings in areas with zero habitat alteration. For cultural resources and recreation, money made from the SkyTram will be used to upkeep the cultural value of the area and keep the area from being degraded by increased public use. Another important aspect to the project was lowering greenhouse gas emissions in San Diego. We calculated the amount of cars that would be taken off the road at max capacity on the SkyTram, and then calculated the average amount of carbon dioxide emissions per vehicle. We calculated that over 7 million pounds of CO2 would potentially be reduced in San Diego from the SkyTram. In conclusion, this project will not have any major red flags in regards to the environment and will improve air quality in San Diego.
Hello everyone, I'm Abelardo Solis and I would like to walk you through our traffic analysis. In agreement with the City of San Diego guidelines for analyzing intersections, I referenced the 2010 Highway Capacity Manual. I also used the Principles of Engineering and Traffic Analysis textbook as a reference. This report analyzed 3 intersections' current conditions to determine their respective levels of service. After this, I used the figures that we calculated when designing the SkyTram to determine the impact the project would have on the intersection's LOS scores. First, I'd like to talk about the current LOS. As you can see, all of the intersections are running at acceptable LOS. The only one that is questionable is the vehicle LOS at 6th and Broadway. Its current LOS is a D. Now the question is, how would the SkyTram affect these intersections? If the SkyTram is running at maximum capacity, it would transport 1,624 people each way each hour. That is roughly equivalent to 812 passenger cars per hour in each direction. That being said, the SkyTram would improve the current LOS. This is a direct result of the decrease in traffic volume. In addition to that, the CO2 emissions could potentially decrease by over 7 million pounds per year.
My name is Norberto Rubalcaba, and I performed the geotechnical analysis. The purpose of this report was to Summarize the existing general soil, rock, and geotechnical conditions at the project site. Comment on the general impacts and constraints that the geologic and geotechnical conditions may have on the proposed project. And provide geotechnical recommendations for the design and construction of this project. Specifically, our scope of work included taking 16 boring samples of where the proposed tower locations were going to be. The image below shows the exact locations of where these boring samples were taken. We reviewed available geologic and geotechnical reports, maps, and historic aerial photos of the site and the surrounding area. We performed a field investigation to explore subsurface conditions, perform in situ testing, and collect soil samples for laboratory testing. We performed a geotechnical engineering analysis, and with that, we performed this geotechnical report. This site is located in a geologic hazards category 52. According to the City of San Diego Seismic Safety Study, hazards category 52 is assigned to level or gently sloping terrain with favorable geologic structure and has low relative risk potential. The most likely geologic hazard to affect the site is ground shaking as a result of movement along one of the fault zones. The materials at this site are not considered subject to liquefaction due to such factors as soil type, density, as well as lack of shallow groundwater. Due to the distance to the shore, it is our opinion that the potential for tsunamis to affect the site are considered low to non-existent. This site is not located in an area that is susceptible to flooding. Known groundwater was within the excavations, and we do not anticipate any major groundwater related problems to affect the site. In general, no geotechnical conditions were encountered that may prevent the development of subject site as presently proposed, provided the recommendations contained in this report are implemented.
Hello, my name is Sebastian, and I am presenting part of the structural report. The initial design involved a standard tower with equally distributed loadings. Space for the towers would be made by taking out a lane and putting in an island. This island would then be further improved upon to improve the scenery of 6th Avenue. However, the final decision was to use a cantilever design so as to have minimal impact on the traffic by having the towers placed in street parking areas. Structural calculations determined that a steel tower can safely hold the combined loadings of the steel cables and 6 gondolas of equal spacing, without failure. Using a vertical sag curve, the sag for the cable was determined for half of its safe loading capacity. This way we can account for any unexpected loads such as a falling palm tree or debris. With a total sag of 30 feet at its lowest point, the gondolas will safely travel over all street utilities. Due to FAA requirements, the structure is limited in its height capacity due to its proximity with the local airport. For safe measure, therefore, the towers will not go any higher than the surrounding buildings.
There are a total of 14 cantilever towers along the route for the tramway to have its most effective impact on traffic flow, 12 of which will be along Cable Loop 1, with an additional turn tower at the intersection of 6th Avenue and El Prado. The cantilever towers will be placed at equal increments of 766 feet apart along the 6th Avenue route. Equal spacing amongst the towers allows for symmetry in the total cable sag, giving the system a more aesthetically appealing look, as well as providing an evenly distributed load on the towers, creating less torsion on the bases. After the 90-degree turn, there will be 2 towers along Cable Loop 2, and then finally descending to the Balboa Park landing site. Once the 90-degree turn is made onto El Prado, the tower spacing deviates from the 6th Avenue plan of having. This choice was made for the following reasons. First, there are no traffic signals that need to be cleared on the El Prado route, therefore allowing for more cable sag between the towers. Secondly, this is the more scenic section of the route, and minimizing obstructing any Balboa Park views was a top priority. A total of 91 gondolas were evenly distributed at 255.33 feet from one another along the entire two-way span of the route. This gives the maximum sag of a span, as there would be one gondola at each tower and two additional gondolas suspended at intervals of 255.33 feet. The gondolas run approximately 13 miles per hour with a 10-minute route time per direction. This allows for a maximum of 1,628 passengers per hour per direction to commute or tour. With these preliminary designs, the aerial tram would alleviate traffic while bringing a modern tourist attraction between two of San Diego's most visited sites. This has been the structural analysis for the San Diego SkyTram.
My name is Daniel Bedoya, and I was responsible for the construction report for the San Diego SkyTram project. I put together a construction schedule after our proposed SkyTram design. We proposed 14 towers at 90 feet high each. As you can see in my schedule, I am considering main material lead times and basic construction phases to estimate construction at 71 days for each tower. I assume that after grading we can move on to the next tower. The total construction time is approximately 2.5 years from the start date. For my construction budget, I included materials, labor, equipment, and lump sum values for main items. I did basic material takeoffs to estimate material quantities. Prices for materials were obtained by calling distributors. Labor and equipment totals were established using workdays and estimated prevailing wage rates. Lastly, I listed main construction items to help our budget proposals so that we have money in for that scope of work. My spreadsheet shows pricing for one tower at $901,000. Our proposed budget is $42,300,000 for the entire SkyTram project. My next slide shows a logistics model for one tower construction site. This includes necessary items to have a safe construction site that will ensure worker and pedestrian safety.
Thank you for considering BRAGSS engineering for the downtown San Diego SkyTram project. I hope you enjoyed this presentation.